welcome back to the second half of the morning, everybody. Business, we have some Twitter handles, if anyone's tweeting. Hashtag ISAIRL or hashtag ISAIEConf, C-O-N-F. So if you're tweeting, use those tags. It'd be much appreciated. So as mentioned this morning, Brian McMahon was unable to make it. So we're going to follow up with Gar McCreasta here, and let me read it. Chief Adventurer at Business Model Adventures. So
you've got to make up a title.
So it's on views, viewpoints, and visual models. I'll let you take it away.
Or rather, it's not. That's what it was meant to be about. And this is the surprise to the conference organisers as well. So I was asked about 2 months ago to do something here, and then I started doing it. Sorry. And then I decided I'd do something else along the way because it was far more interesting than... Who wanted to hear views, viewpoints, and big visual models? Okay, right. So only the people down the back then. Right. So this is actually about CODA and XCC, and we'll get into what they are. And we're going to talk about what the hell it is, why it's important, and where we're going to get to with it. But first, some cognitive recalibration. On your seat, you will find a white piece of paper. It better still be white. What I want you to do with that white piece of paper is pick up a pen. We know what a pen is. Terry, come on. You're going to have to do this. Play a game with me. All right? There is a reason behind this. Everybody's got a piece of paper? I then want you to get said pen, and put on paper and draw some squiggles. You don't have to copy these, but I want to draw some squiggles on the paper. Well, there's about 7 squiggles on that page. You don't have to copy what's on mine. Make your own squiggles. When you're all done, everybody done? Squiggle away? Yeah? Right, now find a bird. A bird has a beak, 2 eyes, 2 feet, and a tail. So you've got to find the bird. Don't find my bird, find your bird. Feel free to turn the paper around as well. The bird may not be in there if you just leave it like this. Are we all done? Right. We will collect the birds at the end. And then at lunchtime or just after lunchtime, we're going to have a vote to see who came up with the best bird. So now that we're all comfortable and all set, and I've cognitively recalibrated you, let's talk about what this is. So what the hell is CODA and what the hell is extreme continuous change? So warning, so this is it's a minimum viable method, which means I'm making it up as I go along and trying to figure out what works and what doesn't work. And we're kind of evolving this as we go. And like many things, and actually all things truly wicked start from innocence. So this started from innocence, with me trying to do the right thing and trying to find different ways to do different things. But the truth is, I'm a very bad person. And I've committed horrible crimes against architecture in my career, over and over and over again. And I've hurt people, digitally, not physically. That hasn't been part of it yet. Right? But I'm tired of hurting people, and I wanted to find new and different and interesting ways to do the things we were doing. And I got a sense that we were missing some tools or a connection between tools. And for me, a lot of it is that the writing is on the wall at the moment. The lifetime of a Fortune 500 company is getting shorter and shorter and shorter. It went from being over 100 years back in the 1930s to projected in 2018 it'll be less than 10 years. You'll survive in Fortune 500. Right? So it's getting shorter and shorter, and that cycle's getting quicker and quicker. So some of the companies that we work for are going to begin to disappear. Right? That's the reality. Your odds of being successful with a strategy and change project are about 3 in 10. Right? They're not great. And they don't seem to be getting any better, and it's not trending in the right direction. And it doesn't matter where you look, and this equally goes to mergers and acquisitions as well. If you look at the rate of failure in mergers, or not failure, but a failure to realize the benefits anticipated from an acquisition, they're roughly the same, those kind of odds. So there have to be better ways of doing things. The other thing is that the level of engagement in our organizations is extremely low. Gallup had a poll, and they poll organizations around the world, and they reckon it's at 86%. Right? So that's people who actually don't like their job, don't want to be there, aren't engaged, don't want to do it. Nobody here, because everybody here, actually, you've got a day off today, so it's okay. But everybody here is kind of engaged in what they do and invested in their careers, but that's not that's not what's happening in the rest of the industry. The bad news for some of you is it's already too late. Your organizations are probably dead, you just haven't figured it out yet. That's the reality, okay? It's going to happen. And why? It's because we keep doing this. We did this session deliberately after the coffee, because if we did it beforehand, we'd be left with a whole pile of food there. But what we indulge in is open heart surgery, right? Every time we go and open up the patient, we crack open the sternum, we pull the ribs apart, we open up the heart, we stick our hands in, and we make a mess. And the chance of infection is quite high, the time to recovery is quite long, right? And this is what we do repeatedly. Over and over again, we go through this cycle. Behind all of this, there are a bunch of other things happening, other things that are changing in the world. And what I will talk about later is based on a very specific worldview, an ideology, if you like, in terms of what I think is going to happen or what I believe to be the truth about what's going to happen down the road at the moment. And I'm experimenting to try and figure this out. But if you look look, this is a bunch of buzzwords, but 3D printing is going to change everything from a manufacturing perspective, Internet of Things, right? A conference on in Carton House yesterday, all of that stuff is happening. Software-defined everything, so it's not just software-defined networks or software-defined, but it's software-defined everything. So everything is configurable in that way. Watson, he's going to figure it all out and we won't need us anymore. Drones, robots. The rule book as it stands at the moment in terms of the organization structures that we've created are fundamentally broken. The changing nature of the job. So if you can imagine in 20 years' time, there will not be a 5-day work week. We will not be working the way we're working at the moment, yet we repeatedly choose to design organizations along a model that has proven not to work, and we keep reinforcing that by designing it to sustain it rather than to remove it. And that's what's happening as well. So if you look at the things that are driving that, emergence of collective, work swarming, routinization. Can I say that word? Deroutinization of work. So all of these things are kind of contributing to this. And it's becoming a challenge for organizations, but it's also an enabler as well, because we want to be able to benefit from all of these technologies, but we haven't figured out a way to respond to them, because we're locked into the past and we're trying to figure that out. The other thing is we've discovered lots and lots of stuff about the brain over the past. And I think Drucker said that culture eats strategy for breakfast. Well, dinosaurs eat brains for breakfast. Can anybody see that bit? Yeah, a bit in the corner. So the different bits of our brain in terms of how they operate, so the reptilian, emotional, intellectual, the bit that we focused on, the intellectual piece, turns out isn't that important, because all of our other decisions are dictated by these other two, or by and large dictated by these other two. But we insist on focusing on this rational view of the world. So we're back to this again. We keep opening up the patient and going through the process of doing this over and over and over again. Everybody heard of bimodal IT? Yeah? Hands up. Yeah? Anybody want to give me a definition? No. 2 modes of IT. So Gartner came up with this a couple of years ago, and they said, right, in order for you to be successful, you need to split in 2. So you've got mode 1 and mode 2. Mode 1 is do what you're doing at the moment, and the characteristics are it's traditional, emphasizing scalability, efficiency, safety, and accuracy. Right? That's what it's about. And for certain systems, that's fine. On the other hand, mode 2 is non-sequential, and it's emphasizing agility. So it's trying to be more agile and responsive in terms of responsive to market needs. But here's the problem, stable and agile. Well, stable is actually fragile, right? And it's more likely to break. And if you look it up, it's about being immovable, and it's fixed. So all of the language is around that. And it's a monolith, right? It's made of stone, and it's hard to move, and it's hard for us to move this. On the other hand, agile is, and up in the top corner that says, can I get rid of this? Watch as I... That's better. Right. It's anti-fragile. So some things benefit from shocks. But we insist on, and it was funny because we were, a couple of us were at a conference in Belgium on Tuesday of this week. I don't just do conferences. But one of the things that came out was the guy started talking about mode 1. Let me go back. Mode 1 and mode 2. And one of the comments he made, I think, was quite telling in terms of our view in the industry of how this works, is that we'll do mode 2, but eventually we'll pull mode 2 back into mode 1. Right? So we'll do all of this cool, innovative stuff, and then we'll pull it back in. Because we couldn't really consciously allow ourselves to think that our organization could run fully in Mode 2. Now, this morning, Liam talked about Netflix. Netflix is a Mode 2 organization. They run in Mode 2. This is what they do. Everything is about being able to respond to evolutionary change in their environment and being able to do things like that. Being resilient, right? They love adventure, they love risk, and they love uncertainty, and they've developed capabilities to be able to respond to some of those things. And that's the way they've built their business and built their business model. I think if you look at the organizations that a lot of us work for, that's not the case. We haven't. We've built for stability, which seemed like a sensible thing to do, but as it turns out, it may not be. Right. Actually, let me go back here for a second. What I'm going to talk about in terms of what CODA is and what XCC is a Mode 2 method. Do not try it with Mode 1. You're wasting your time. It's just not for it. This is for Mode 2. Mode 2 only, and that's where we're going with it. I think one of the challenges is that we think we're actually doing this. So we think we've got a microprocessor, and we're slowly refining it and making it faster and making it smaller and doing all the things that we have done within the industry. I should have pointed out this is metaphor heavy, right? So there will be a metaphor for nearly everything. If you're not happy, it's probably time to leave. And we're going smaller and smaller and smaller. But what I actually think is happening is that we're going from this. So right now, we have business models that are vacuum tubes, and we want microprocessors, and we're trying to go from one to the other, and I don't think we can. Right? Because it's a jump, and we shifted. It's a paradigm jump. So I go from that to this. Right? Anybody know what that is? Keyhole surgery. Right? So what CODA is a way to do keyhole surgery in your enterprise, or at least that's what I'm aiming for it to be. So let me talk to you about where this came from. So actually, and many of the people are in this room, one of the benefits of Iasa, I will just say as a plug for Iasa, is the ability to have conversations about weird stuff like this with a random selection of people who happen to live in your country. That's one of the real benefits of it. But what I've described this as is method mashing, and it's banging things together to see what sticks. And these are not an arbitrary collection of things. It's a slow incremental process of trial and error, of empirical research to try and figure out what works and what doesn't. So I go back to my previous point about having hurt some patients in the past. I don't think any of those patients are here, so I think it's okay. But trying certain things, so looking at things like, so design thinking, introducing some of the tools and techniques from design thinking to help us understand what's going on and understand, and to what Siobhan was talking about earlier on, understand the customer's journey, understand their experience of a product or service, looking at things like lean, so how do we optimize, how do we make it efficient, how do we look at the effectiveness of something. Event storming on domain-driven design, so looking at and it's bits and pieces and disciplines from all over the place. So it's some stuff from software, it's some stuff from lean, it's some stuff from design thinking and product management, from innovation, from all over the place. And then taking in stuff as well, because I guess my goal is we're looking for this way of modeling and understanding a company to give us a language to be able to articulate what we're changing, right? And then to give us the tools to explore and experiment with those things to try and move that in the right direction. So taking blue ocean strategy, business capability modeling, popcorn flow, which we'll come back to later. Plug for Claudia's talk after lunch. Please have to stay around for that one. Management 3.0, which are next generation management techniques. But all of these things are part of this new world view of how an organization will work, as opposed to this traditional stable view of how organizations do work at the moment. And what I'm saying is that this model is for the future and not for the past. Things like, who's heard of holacracy? There we go. One. It's a new way of managing organizations without managers, right? No managers. It all works in circles. It forces collaboration, collaborative decision making, advanced meeting techniques, all of the stuff to make all of the drudgery of what's happened in terms of the command and control structures that we've introduced, to make that go away. That's what they're aiming for, right? Not sure are they going to get there, but it's how do we learn from some of these things as they're beginning to evolve? And it's taking all of these bits and pieces plus the tools that support them. And the big thing that I'm keen on is that this is not an abstract conceptual framework. This is a thing with a solid set of tools underneath it that are proven to work in different contexts, in different domains. Business model canvas? Yeah? Okay. Business model canvas, modeling your business on one page. That's fine. Now, experimenting with different features of that business. The value proposition canvas is the bit underneath it to explore the value proposition for that. The customer experience journey. Who's seen customer experience journey mapping? So this is the experience a customer has of your product or service through its life and every touch point, from the bits when they don't know about you to the bits where they have you, through after-sales service, through to its full lifetime, and understanding both the pluses and the minuses, the positives and the negatives. What else have we got here? We'll get back to the jobs to be done stuff later. In the top right-hand corner, business capability models. Who's got a business capability model built for their business? Keith has. 1, 2, right? This is a model that articulates what your organization does, and that's stable over time. And bringing all these things together is really my objective with this, was to kind of merge these things together. And a light bulb went off maybe 6 weeks ago in my head, and I went, if I take this and turn them that way and connect them, it all makes sense now. And that's kind of the place where I ended up. It was a very strange place for a little while. I was highly confused. I think I've resolved most of the issues that I had there. But what emerged from this was CODA, so Customer Outcomes Driven Architecture, right? Siobhan talked about it earlier on, customer outcomes. And it was funny because it was as if we'd rehearsed it. Siobhan kind of set up for, here's how product management fits in this space. And you go, cool, right? And I don't care who does the job and what their title is, the job needs to be done. Somebody needs to do this stuff to connect. So the first thing is, and what it's for is keyhole surgery for your enterprise, right? And it's moving away from the big open heart surgery where we tear your body apart, stick our hands in, infect it, make it worse before it gets better, and maybe it never gets better, to a very focused, precise way of understanding what we're going to fix and for who and why. I always ask myself, what would Tony Stark do? In nearly all situations. I don't often have an answer for it. But the first thing is that we all acknowledge that customers are important. Yeah? The most important thing. Yeah? No? Have I lost everybody? We'll get back to the birds? No. There was a guy called Theodore Levitt, and he said, people don't want to buy a quarter-inch drill, they want a quarter-inch hole. Okay? And that's what this boils down to, is that if you're looking at what customers want, right, it's not what they say, and Siobhan's, I'm going to keep referring back to you, Siobhan, sorry. It's not about what they say they want, and to what Claudio said as well in some of the questions that were going, but it's about the jobs that you're doing for them. So people hire products and services to do jobs for us. That's what they do, right? So our job then is to understand what job we're doing for them, and then how well we're doing that job. So beneath this, I've got, and these are, as I said, it's a minimum viable method, right? So I'm pulling it together, and I'm intentionally and deliberately keeping this light. So you don't get fancy models at the other end of it right now, but it is all tool supported. Business model canvas up there for a simple bank. A simple bank delivers a value, is there a, hold on. There it is. A value proposition, right? So here's what the customer wants. The customer has some gains they can achieve, some pains that they're suffering from, and the jobs. So what jobs are you doing from them? Those jobs have a structure. So there was a guy called Alan Clement who decided, okay, so I'm going to create a job story. You know, who's using user stories or Agile? Yeah? So this is move it up a level and move it out and focus on the customer. It's a job story. So it's in its form of so what's the situation? I want to, right? So I can do something else. So in this case, so when I have no money at the end of the month, which was a common situation back in college, so I want to figure out where it went so I can go on a skiing trip next month. So I don't just spend it all in one place, right? That's a very trivialized example and not a well-formed job, right? But that job has a structure, and that job, in this case, is a functional job, but jobs can be of different sorts. So I've got jobs that can be functional jobs, social jobs, or emotional jobs. And the vast majority of the work that we have done as an industry has been focusing on the functional jobs only. So we've been trying to address the functional need without understanding the context around it. And if I go back to the dinosaur picture I had earlier on, the dinosaur brain, right, which is the survival piece, I've then got the emotional brain, right? So the emotional piece makes a decision. We're trying to appeal with our features to this rational brain, right? And we can't, because the emotional brain overrides it. And we make our decisions somewhere else. So it's understanding what jobs we do for people in what ways and why they buy. So they buy why we do it as well. And then it's looking at mapping out those jobs into a job map and understanding that there is actually a universal job map. There's a guy called Tony Ulwick from Stratogen, a company called Stratogen, and he defined this and he said, any job can be mapped to this. So you can define, locate, prepare, confirm, execute, monitor, modify, and conclude. They're the steps. So here are all the steps that you can take. So these are the places that customers play. And what our job is to figure out how do we serve their needs better? How do we do a job that's not done well? And I can then map it into this ugly graph here, but it says the satisfaction of something and the importance of something. And really what I'm focusing on here, so I can disrupt in there, but over here I'm looking at unserved needs. And I'm looking at scoring and weighting them. And I have an algorithm. So the opportunity is the importance plus the max importance minus satisfaction, right? That's what I'm looking for, so I can score it. And then I can come up with a method for doing it. And again, this is all about having different tools to be able to weigh, score things, come up and understand that I'm making the right decision, or that these are the decisions that need to be made. All right. Have I lost anybody so far? Has anybody any questions? You're nodding.
I don't quite get the formula yet.
We'll come back to the formula. Actually, you know what? With the presentation, there is at the end, there's a set of links which give the white paper for it, and it's much better to read the white paper. So I would suggest this is a short circuit into a body of research, right, as pointers into different things that I think are important. I think it's important not to just take that and apply it. It's important to understand some of the constructs behind it as well. So I'll send on the white paper as part of this too. Blue ocean strategy. Yeah, this is cool. Anybody who's done an MBA has seen this. That was a way of looking at how an organization competed for a product or service in terms of what were the differentiating features that it had and how could it do it. So if you take the Ryanair comparison, so you had high-cost airlines like Aer Lingus. Ryanair came in with a low-cost model, right? Low-cost model, no frills. Aer Lingus had frills, lots of frills. They weren't that frilly, though. But so we had situations like this, and it's a way of mapping out these different things. I'm going to get rid of this flip chart because it's... Can everybody see the bottom right-hand corner now? I'm wishing I hadn't put it there. And mapping this. But the problem was that Blue Ocean strategy actually was it took a feature mindset in terms of how it saw the world. But if you adapt it and put jobs along the bottom and rate it this way, now I can see how I can compare against somebody else. I can see how I can compare against my competitors. Am I doing a job better or worse than them? Is this a job that I want to do? Am I just going to remove it? And I can apply different frameworks to it. So that's the first bit. So that's the outside. So that's the customer and understanding the customer. So I've got this jobs to be done framework with a whole pile of other tools around it to help me understand the jobs I'm doing for them and the ways to capture it. And it all focuses on, sorry, Siobhan, back to what Siobhan was saying, getting out in the field and asking the questions and understanding it. It doesn't matter who does it. That's the key piece here. It could be a product architect, right? Or it could be a product manager. Or it could be a business analyst. As long as the tools are used and the information is captured, that's what's important. That's the goal of this, so we understand and have a clear understanding of what jobs we're doing for our customers. The second piece, so now I've got a clear understanding of the customer, what they want, yeah? I can see all the jobs that I do for them. I understand what jobs are not served well at the moment, where there's an opportunity for disruption in industry. I can look at that and I can develop a strategy around that, so I can build something out of it. The problem we've had so far in terms of if a product management team was doing that was how do we respond to that from an architecture perspective? How do we, because what we end up doing is trying to fix everything, right? So we put in a new platform, we fix everything. But we don't fix anything. We try and fix everything, so we end up going nowhere, and we just end up running in a circle. So the second part of it is how do we understand the internals of our organization to be able to bring these two worlds together so we can get to that keyhole surgery view of the world versus the open heart surgery view of the world. Capabilities are what we do, not how we do it, right? Doesn't matter if we faxed it 10 years ago, we're emailing it now, and we're sending it via some weird messaging infrastructure, or it's going as an Internet of Things thing in the future. It's the what. The what is still the same. And it all boils back down to the business model. So in this case, it's not looking at the customer and what they want outside. It's the others. So it's the backstage. So it's how we respond to that. So it's the activities that we do, the resources that we have, the partnerships that are in place that allow us to deliver through channels and relationships to deliver something of value to a customer. So it's taking this piece, which is the other side of the value proposition canvas, and blowing that out and saying, okay, our gain creators, our pain relievers, and our products and services map onto our business model and give us the ability to do something. And this is taken from, so anybody here from a bank? Nobody's saying. I laugh because Alistair's only in a bank for 3 weeks now. Anybody here from a central bank? Loaded. I'll say nothing. But this is taken from the Banking Industry Architecture Network. So it's a reference architecture for a bank. So what would a bank look like if you were to draw it as a set of capabilities? And then how can I reorganize that? So it has a capability called sell product and deliver service. Well, I've actually renamed it because I'm an architect, I get to disagree with another architect and tell him that my version and wording of this is better than his. So I'm saying it's sell product and deliver service, capture customer behavioral insights, identify spend patterns in customer event history, obtain customer credit rating, evaluate customer product options, make offer on appropriate savings products. Now, as architects, we can see that's all in English. So I can talk to somebody in the business and I can go, that's what you do, yeah? Okay, great. Now, what do you do it with? Well, we use this piece of technology, we use these people, and we have this process, or we don't have this process. And we do it in these places, these policies apply to it. We need this information, and we give this information to somebody else, right? And that's ultimately how we construct this. So I can then build out a capability model. Actually, let me go back to, I wish I didn't do that, to this one, like this, which is a fairly big capability model, but I can draw it out of the what's of an organization, so what it does, right? And that's what I want to be able to articulate, the what of what it does. Now, the next piece is, come on, to be able to connect these two worlds together, because which capabilities support the jobs that that we need to improve for a customer, right? So if we've got this underserved job on the outside that a customer has, and we're not doing anything with it, or we need to improve it, what are the capabilities that collaborate together to deliver that result to a customer? And then I pick from my capability model the ones that I think are important, and they're the ones that I focus on not fixing, but generating options out of. What could I do to make this better? Could I get somebody else to do it? Could I do it better? Could I get a different piece of technology to do it? How could I do that better? And this is not about a prescriptive formula for planning around it. It's about driving out options around how could we improve this, right? How could we make that job better on the outside as a design tool and a thinking tool to help us explore options around it? Okay, so I'm going to say our business services on the outside is what the customer sees, supported by business capabilities and a chain of capabilities that can be scored and rated in the same way we did the job, using a different formula to look at how does it contribute to our strategy, how does it contribute to, or how does it impact our customers, and then how much value, how much financial impact do we generate from it. And I can look at all of those things. I can look at efficiency, I can look at effectiveness, performance, maturity, and a bunch of other variables to figure out a way of measuring where we are and setting a target for where we would like to be, and then exploring options for how we would get there. So as opposed to the way we do it at the moment is, we're going to fix all of this stuff, now we want to fix just these bits. And actually, we don't know what we're doing there, and here we know we've got something that we need to fix, right, and we need to do something with it. So it's really trying to articulate how the business responds to a customer job and what we will do with that. And ultimately, we end up with this. That's meant to say fix your what's, not fix you what's. I don't know what you what's are. But so we need to find the right job to fix and then fix the right job. So it becomes this keyhole way of looking into our organization and across it. So we're looking across and going, what are the capabilities that collaborate to do this job for this customer, and how can we fix them? And doing it in a rapid, agile way as opposed to the big change way. So how can we explore and experiment with small little changes that the net effect of all of them will contribute to improving the job for this customer? Yeah? Making sense? Yeah? Okay. Right. And CODA is experimental, so it supports experiments. It's precise, so it's targeted. Oops. Don't worry about that. It's expansive, so it can go out and across the organization. And one of the challenges, as we talked about the Mode 1, Mode 2, is that in Mode 2, if the assumption is that we pull Mode 2 back into Mode 1, I would actually argue that we actually want to pull Mode 1 into Mode 2. So if we can figure out different and better ways to deliver these services faster and faster and faster, then we can adapt and change our organizations better that way. And learning how to do that is more important. And it's emergent, so we don't know what's going to happen. So we can respond to this unknown piece as things are changing. Because we're making these small changes, we're doing them fast, and we're doing them iteratively. Whew. That's part one. How are we for time? I have to, yeah, we're okay? Right. Extreme continuous change and the stability dilemma. So there's a guy called Danny Kahneman who did lots of research around the brain, right? He's a behavioral economist, right? And he was looking at how people respond to different stimuli, what our biases are, and things like that. But what he said was that the idea that the future is unpredictable is undermined every day by the ease with which the past is explained. Okay? We post-rationalize everything. We go, I know why that happened. It's just the way it works, and it's okay, right? We have these things that we do to people at the moment. So who's got change zombies in their organizations? Let me define a change zombie for you. A change zombie is someone who has been through 3 or more change programs and has seen nothing change. Yeah? They will now get into... Have you ever seen them get into the change zombie rage? Yeah, they get into the rage because it's another change program, and they know it's futile, and they know nothing is going to happen. But we've created this army of them, right? A whole nation of them that we're having to deal with at the moment. And what we're trying to do is just give them one more little change, just one little wafer thin mint, and you'll be so much better, and it'll all be okay. But it's not working, right? And the way we've been doing it, it goes back to the previous point about the open heart surgery. What we've been doing hasn't worked. John Cotter, who is one of the fathers of change. So why does change, which can be so exciting and lead to so many great opportunities, burn so many people out? The short answer is change efforts are all too often unfocused, uninspired, and unsuccessful. Our research shows 70% of transformation efforts fail. That's your 3 in 10 chance, right? 70%. Burn out and burn so many people. People are tired of it. They're jaded by it. There has to be a better way of doing this, and that's what this is exploring, different ways of doing it. And it does feel like this, so we're going in circles, right? We keep coming back around. I remember talking to a guy last year who was telling me he'd been back to a large telco, not here, somewhere else. He's doing the same project for the 3rd time, all right? The first 2 times it wasn't successful, but you know what, damn it? There's no better way to burn €1 billion, right? Okay? But we keep going through this cycle. And what we do from an architecture perspective is that this is the business model. We pour quick-drying architecture in there. So we tie people to a past. We put in all of these systems and we keep them there, right? So we create these structures that don't allow people to flex. Anybody disagree with that? We try not to, but we do. Nobody's admitting to anything in this. Everybody's got the poker face on. So, this guy's a plater. I'll point the laser pointer at his head. Right? So Claudio said, do you want to quote? And you're wrong. If change is hard, make it continuous. Because we go, if you think about what we've done, and to go back to the stability point, we create this illusion of stability where we think we go through these long periods of stability. Short periods of instability, long periods of stability. And we've designed our organizations to crave that stability, instead of driving change into the heart of our organizations, which allows them to understand that it's all about changing all of the time, and that the faster you do it, the better it is to keep doing it. And I'm not going to harp on this because he's going to talk about it later. So Hagar, that's mine. Shut up, right? No thunder stealing or spoilers, please. But we will talk. And I had 2 or 3 slides on popcorn flow, but popcorn flow is going to be delivered to you by Claudio after lunch, so we're not going to talk about that. What I am going to leave you with is that in the end, what we're doing is all about agility. What we're trying to do is enable our organizations to engage in new markets, right? There's a lady called Rita Gunther McGrath who she wrote a book called The End of Competitive Advantage. She's a top 50 business thinker type person, and she talked about how we have this illusion that we've all been aiming to get and sustain this competitive advantage, and that we keep it over time, but actually that's flawed, right? We can't. So what we're facing now is that we have a time and a place, like an arena, and we need to be able to get in, but also to get out. And we're not designing our architectures to get in and get out. We're designing our architectures to get in and stay. Yeah? And that's the piece that's holding us to the path, because we're not thinking. We're thinking about the 15-year timeline as opposed to changing, and what that would look like. And all of our models are built around that. So our ability to engage, to build experience, and to disengage becomes really what's key to us. And your architecture either enables or constrains or enslaves, maybe, might be better than constrains, your business model. So what we need to be focusing on then, and what this ultimately ends up in, is how do we build architectures that we have an engagement architecture to get in quickly, to get the most value out of a transient advantage, and then to get out at the other end. So how can we exit quickly as well? And designing and thinking around that to get in and get out, and to make precise changes so we can do those things quickly, rapidly, and with a level of comfort with the uncertainty around some of the changes that we're making. So the Buddhists had it right, because they had a term for this, which is viparinama dukkha, which is what we've forced our organizations to suffer from at the moment, which is the anxiety or stress of trying to hold on to things that are constantly changing. And we've got an industry that's built around this at the moment. And what CODA and extreme continuous change and the variety of different, I guess, rapid evolutionary change models that are emerging, right, we'll talk about that one later, are trying to do is to figure out ways to be able to respond to this, right, in a way that makes sense, but also from an architecture perspective, that we can take ownership and hold of this, that it doesn't feel like we've let the horse go. So we need better tools to be able to do that. But what I do think and what I believe is that it's the beginning of a great adventure. So are you ready for it? And that's really where I need to leave you today. So are there any questions? There was a lot in there. No? Yeah? Go on.
Keyhole surgery.
Yep.
You really want to know how your organisation and the documentation and just that mapping of your organisation, because otherwise you're just poking into the dark.
Yep. I think the business capability model is that's the right level to go in at. So some of the tools in here, but in terms of the method to do it, if you're trying to do that change in an organisation in terms of how you're structured at the moment, it's difficult to do all of this stuff in a mode 1 type organisation because it's constantly being pulled back. So you need to clearly separate it and say, okay, so this is the one where we use all of this as a method to do it, but we can still use some of the same tools over here to help us understand what's going on, to try and pinpoint the changes in there. And that's what some of the tools are. It's to articulate what the current state and the change state are in our organisation. And I think they've been not widely understood or well understood to date.
I think it's a good point in that to make change, you have to really have an accurate current state, and it has to be always maintained. We don't build organizations to maintain that current state. We can do that change.
No, most places, like especially ours, by the time you actually document it's already changed.
Yes.
Some place that we documented 2 months ago, so
Yeah.
it's a constant fight.
Yep.
Yeah, well,
I saw the name tag earlier.
I was trying to marry the over that continuous change with that get in, get out.
Mhm.
Do a bit concrete and maybe explain that a bit.
In terms of why,
Well, if change is continuous and you want to,
but it's the ability to design things to get out. So it's your ability to do it, because we're putting in and we're designing architectures to be able to get in. So we need to be able to respond to the fact that the market's gone away and get out as well. So it's the other end of it. But it's thinking through the full life cycle, because we talked, like if you look at service management in its entirety and the bit around sunsetting, that's the bit that's least well understood. And part of it is because we haven't considered that up front, right? We haven't considered what we're doing and how long it will last and how it will respond to these things. So it's creating architectures that can respond to the extreme continuous nature of change in the organisation. That's kind of the point. Yeah. Dynamic. Yep.
It's interesting. I worked for a company that actually was really good at change, and they were great at that kind of stuff. And that's kind of in the mode 2 one.
Mm-hmm.
But the thing that's bothering me is what they turned out to be really shite at was actually picking the right things to do. So because they did the $1 billion,
Yeah.
and then they realized actually no, they just shut them down.
Yeah.
So I think mode 2 is that quick continuous change. I think mode 3 is how you turn yourself into a platform where new people can throw stuff in, and you become you don't actually care, but you just the important thing is to have enough volume.
Yeah.
That's enough will actually succeed, and it takes off. But it's then I'm stressed because I'm kind of thinking, oh dear God, there's another mountain beyond this one.
Well, I think one of the interesting things is that if you look at I'm done with this comment, so you're fine, Connor. I got the 10-minute warning. I was going, we're filling in because of the missing speaker, so the timing's a little bit off. If you look at our evolution in terms of the monolithic systems we've built, and what we seem to be doing at the moment is going from these monolithic systems and kind of getting smaller and smaller incrementally. And then at the other end, you've got guys like Netflix and Gilt and a few others who've gone for microservice architectures, right? So they've gone deliberately for tiny stuff, but it's complex. But they've built up capability in terms of managing that complexity. And what we seem to be trying to do as large enterprises is go from these big built systems like the SAPs and people like that and trying to go from here down to here and expecting that we can do it. And I think it's fundamentally different. I think there's a break, right? It's a way of, we have to re-architect and rethink how we're doing it. And the platform providers that we're using are not going to bring us there quickly. So there's the banking conference we were at on Tuesday. They were talking about an Indian bank who they're building from scratch, right? So they had the benefit of having a clean sheet, but they were building a microservice architecture in order to be able to do this, to be able to respond quickly. So when your smallest unit is something that is substitutable at this low level of business capability in your organization, so I can whip it out and put something in, or I can give it to a partner, or I can take it back in, or I can get somebody else to do it for me, or I can support different forms of working where I'm not having to hire somebody to do it. I can look at different forms. So who's heard of micro-careers? So there are people now who are coming out who are having micro-careers, which are lots of small little careers, doing lots of different things and having lots of jobs simultaneously, right? So that's an evolving form of work that's happening. And rethinking the organization in terms of how we would support some of that stuff, I think is critical from an architecture perspective, because that's something that's going to happen, right? And it's going to happen to us. So I think if you look down the road and you take, to get into the nuts and bolts of how we would do some of this stuff, I think the microservice architectures that are emerging now, and it's well worth looking at what, and I think Netflix and Gilt are probably the guys who are kind of leading the field on this. It's well worth looking at what they're doing, because what they're doing is fundamentally different to what we've done in the past. And in terms of connecting the dots, the only way to even think about getting there is to have some of these tools and models to be able to understand what it is and how I'm going to respond to it. Right. I think that's it. Thank you, everyone.
So good morning, good afternoon. That's me, Chris Chedji. I suppose a little bit on my background. I did the first ever pure computer science degree that came out of Trinity College, so that dates me. I've worked with a bunch of companies in Dublin, and then I moved to Canada, spent the 90s in Canada, including working on this construction here, and worked on very large kind of military, defense, aerospace kind of projects, right? A lot of communications were in there, and there was a consistent theme, which was we were trying to do things, and we had specs that said you're going to do things a certain way, and it was kind of like the way the hardware guys did stuff. And it didn't really work for software. And I kind of decided at some point that it was just too hard and that there was a better way. And really, since I came back in the early part of this century, I've been working with, initially it was called Headway Software, subsequently we call ourselves Structure 101, to work on technologies and techniques for managing this strange stuff that is code. Okay, so let me talk a bit more about that. Working on this project was fascinating. Okay, I worked on the Canadian portion of it, which were these various robotic systems here, and these are really cool devices that can walk around the station for maintaining it and what have you. Not a huge amount of software, mind you, involved in the control side of that, which is what I was working on, but enough that the problems that I'm going to talk about were very manifest. And what was really interesting is you've got all kinds of engineers who work on this. We had, there was the mechanical, electrical, electronic. There was even, believe it or not, there are guys who are career space lubricant engineers. Okay, which is a big challenge. Any moving parts in space in a vacuum and freezing 1 minute and really hot the next minute, amazing. This is all they do. Okay, and all of these guys had the envious kind of position where they could kind of define. They knew what they needed to do. They had a budget in terms of weight and power and what have you, and they draw up their designs, and they were pretty sure that as long as the design was implemented correctly, it would work correctly. And then they could all go off and they could all work in little groups, and each group would build what they were supposed to build, and they'd plug together, and then they'd do some testing, okay, a bit of debugging, and that would kind of work. Of course, the software side doesn't work quite as cleanly as that. What we're working with is stuff that looks like this. Millions of lines of this stuff, okay, which kind of has some structure, okay, but kind of doesn't, okay. In fact, what we're doing a lot more of, every single project, even one that's been done 1,000 times, 1,000,000 times before, is kind of an R&D assignment, okay. You're redoing stuff. It's quite different from the spec and implement kind of world that the hardware guys are working in. So we do indeed structure this, otherwise we couldn't do anything, okay? And we do things like this. You don't know if you can really see there, but these are expanded boxes that contain other stuff, and then there are dependencies between the stuff. And these things are classes, let's say, okay? And what we're looking at is organizing perhaps a few thousand lines in each module or class or whatever file, and that somehow or other that kind of abstracts up to a new level of abstraction here where we can rationalize and understand this picture, okay? And that kind of works great until you have tens of thousands of these things, okay? And then you're back to the same problem as you had when you just had lines of code, okay? Your building blocks are kind of bigger, but you have a big complexity mess. And what this is supposed to represent is the dots in it are actually classes, and the gray stuff are interdependencies between the classes in a code base. Okay? This is really complex stuff. Okay? And to try and manage this without some sort of higher level abstraction would be stupid, right? Okay? We wouldn't try that. So we don't. We kind of organize these things. So in the case of Java, we organize them into packages. Maven projects, jars, whatever. And we kind of recursively do that, okay? In a kind of a hope to somehow alleviate this problem, right? We wouldn't just throw them all into one big file, into one big directory. So the question is, does this serve the purpose of an architecture, whatever we need by what do we need at the higher level, right? Does it help us, okay? So what I'm going to do is just sort of make this kind of compositional tree view thing into a 2D representation so we can look at what really matters here, which are the interdependencies between the items that we're looking at here. Okay? And if I zoom in a bit there, what I see is something that looks like this, almost invariably. Okay? Unless your team is actively monitoring these dependencies here, you will end up with everything kind of using everything else. Okay? So this is what I mean by, in the title of the talk, emergent structure. These dependencies and this structure is all emerging from the code. Okay? And what we want to look, what we're trying to do with our products and techniques and what have you, is try and marry this to something that makes sense to you guys, to the architects, right? How can we kind of get from this stuff that does have structure, and some part of that structure fits into what you would call an architecture, and how can we rationalize about that? How can we control it? So you guys are not just sticking stickies on the wall in the conference room, right? What you're looking at really is, it's real, okay? And in some way, it marries into your architecture. How do we control that when now we're all going agile, right? Everything has to change all the time, okay? So that's what we're looking at here. And what's really interesting when you look at this. And I've done a lot of this with companies where you can go in and take a code base where the code itself has been organized into whatever structures, packages or projects or whatever. And you look at that and it's a big tangled mess. It's a horror story, okay? And without thinking too much about other considerations, you can organize that in a different way. You can say, take the same files and you can organize them so that you end up with something that looks a bit more like this, okay? Because it's emerging up, the dependencies in the background, in the source level, this is the raw material, if you like, is emerging up through these compositional groups, okay? And if you just organize things a bit differently, you could end up with this or this as being two different organizations of the same code base. Now, it's not quite as simple as that. Sometimes the raw material is itself very tangled and highly coupled, okay? And then you have to address that. But to a large degree, the way you organize stuff has a huge impact on how the structure and ultimately the architecture is structured, okay? Now, does it matter? That's a good question. Why do we need this stuff? I think as architects, as developers, you kind of intuitively know that simpler is better. Given two alternatives for the same solution, right? Simpler is better. And part of that is the sort of reasons we want to use this structure and architecture are things like, you know, it's a roadmap for the developers. So they're not just working at this level down here, they're working at some sort of abstraction layers that they can understand. They drill into the detail they want, but this gives them a way to work, gives them something to go on, and that makes them quicker. Okay, it's not just to make them feel good, oh, that's good too, right? But it's to actually let them move a bit quicker, right? Make them more agile, okay? Phase testing and release is a big one, okay? If you've got a code base where you can't separate out the chunks, any chunks, into ones that you know what depends on them and what they depend on, then you can't really separately develop, test, release that chunk, right? If you think about it. Everything uses everything, then everybody needs the latest version of everything. It's no good. What we really want to get to is kind of like the hardware engineers do, right? They release a component, and then the guys who want to use that component plug it into their circuit board and try it, okay? If there's a new release, they have to upgrade in a phased way, right? The new stuff gets moved down to the dependent things, okay? Modularity, okay? This is software engineering 101. Right? Modularity is good, okay? If you hide stuff and then expose specific stuff, then you're dramatically reducing the effect of change. Okay? You're making things much more susceptible or much more accommodating of change. Okay? The ability to reuse or replace subsystems or layers. Right? You can't replace an item which is completely entangled with the rest of the code base. Well, you have to replace the whole code base, right? But you can't just take out an item and plug in a new one. Okay? It's not going to happen. Impact and regression control is a big one, right? When a code base gets to a certain size, you'll always find, like, you get this kind of moment where you're starting to realize, oh shit, right? We used to be able to predict how long it's going to take to release a new feature, right? Now I'm looking at this code base, I actually don't really know. I think we have to drill in and do some changes here, right? What's the impact of that? Well, let's do the changes and see what breaks. Then you move on to the next thing and the next thing. And guess what? You probably come back to where you started. Okay? And that's where you're losing control now. And that control, not only does it take time, but the lack of predictability is very expensive. Okay? And that's what, you guys, I presume, your business bosses, put a huge amount of store in predictability. Right? They really get nervous when things are unpredictable. Okay? And new developers, et cetera, et cetera. These are the kind of things that we want to get out of a good software structure and an architecture. Okay? Here's a guy, I don't know if you guys come across them, but simple architectures for complex enterprises. He also wrote an interesting, more of a paper, I think, than a book, but the 13 Laws of Highly Complex IT Systems. So I'll skip over this fairly quickly, but Law 10, complexity is an undesirable architectural attribute of an IT system. Okay. Then he lists the sort of things that it's undesirable for. Okay. Pretty much everything. Complexity kills everything. Okay. It's horrendous. It's the enemy. Okay. Okay, but software is complex stuff. What can we do about that? Complexity is driven by interdependencies. Okay, so here's the clue. Okay, here's the clue. There is something, if we can do something about interdependencies, then we can do something about complexity. Okay? Again, he sort of takes another example here of two implementations of the same system. And depending on how you dice and slice, you end up with something design 1 or you end up with something design 2. You have control over the interdependencies. If you count the number of arrows, there's way fewer arrows down the bottom here. Okay? So how you do it is very important. Very hard to get hard numbers on anything to do with software process. We wish we could, right? Because it would make life a lot easier. There's one study from the MITRE Corporation, which I think was done for the US DoD, where they basically ran the same project twice. Said, okay, we have some code. We're going to take that code and we're going to take two teams of equal capability. And one team is going to first restructure the code, okay, and then apply a new set of requirements to that code base. The other team's just going to go ahead and do the new requirements. And this is what they discovered. Okay? For half the time it took, half the cost, and 8 times fewer bugs. Okay. Another one. These guys took a slightly different approach. They did a statistical correlation. They looked at the code repository of a project, a number of large projects, I think. And they did a statistical correlation on the number of defects, the productivity, and other measures based on the dependency structure of that part of the code that was changing. And this is what they discovered. Okay? There are 3 times the amount of defects typically in areas, and you can go into this, follow this, and you'll see, what they consider to be architectural complexity. But it's all around the areas where which are highly coupled, right? Those kind of areas had a lot more defects. It was much more expensive, twice as expensive to create, to do change to the code. And this one's an interesting one: 10 times the staff turnover. So guys working in areas of high architectural complexity just lose the will to live, I think, and they start moving on to other projects. I mean, who wants to do that? You get this feeling of wasting time, right? Chasing your tail and just futility, right? You like to feel when you're putting in a day's work that you're kind of getting somewhere, and you don't get that feeling in a very complex system, okay? Especially if it's unnecessarily complex. So what can you do? Well, reducing coupling is a good thing. Okay. How do we do that? So a couple more points on this. Neil Ford from ThoughtWorks. In software architecture, resource constraint is not the big expense right now. It's coupling. Okay. We've already talked about Roger Sessions. Complexity increases exponentially. Okay, so there are tipping points. Okay, when a project progresses, it gets to a certain point. If you're going unconstrained, the complexity will lead to more complexity in itself. Okay, and it feeds on itself. And he's guys working with C++. That's interesting. There's a book that was written in the 90s, Large-Scale C++ Software Design by John Lakos. He talks about cumulative component dependency. Okay? Another key attribute of dependencies is they're kind of cumulative. So if you depend on a piece of software. One piece of software depends on another piece of software. It kind of depends on all the pieces of software that depends on too. So this is all a way of thinking that kind of gets forgotten. We need to surface this somehow. Okay? And a key one is dependency cycles. Okay? And we kind of saw that in that example I put up where I zoomed in. You could see, actually, if you look closely, it's not so much that there are a lot of dependencies. You're going to get that, right? The problem is that everything uses everything. You've got cyclic dependencies going on. If everyone started out, there's a bunch of stuff that uses, that gets used. You've got a layer that uses that, another layer that uses that, and you build up a system that way. It's great, okay? And in terms of CCD, here's an example of just that, okay? You can't really see, but all of the dependencies in this dependency diagram flow downward. And it gets a CCD. It's a number that measures connectedness, okay, of 164. Okay. If we introduce a single dependency here, for sake of example, okay, the CCD goes up to 1200. It goes up an order of magnitude in terms of overall connectedness by this one measure, okay? But it is a lot more complex. And if you're looking at this and you're thinking, well, okay, so take that out. It's not a big problem. But the problem is you don't have one of these, right? You have dozens of them, hundreds of them, thousands of them, okay? In fact, I call this thing a structural go-to. It's the go-to statement of the noughties. Okay. So the next thing to realize, of course, is you're going to need a bigger tool. Okay? You're going to need something that parses the code for you. I mean, the reason you need a bigger tool, what you see, what your developers see we're talking about code here. So how are we going to rationalize about that code? Well, you've got an IDE. And when you're looking at the IDE, you're right down in the details. You need to see what's emerging from all that detail. That's why you need a bigger tool. Okay? So you need something not like Visio, right? Something that actually parses the code, right? And then somehow shows to you a hierarchical dependency model, right? All three words there are very important. It's hierarchical because you need to understand how the code is organized into bigger and bigger abstractions, okay? Bigger and bigger chunks, containers. It's the dependencies are important. So it's how the dependencies are rolling up through those structures. And it's a model, right? It's not a pretty picture. It's something you can interact with because there's so much information in what we're talking about here, okay? Multi-million line code base, organized into containers, and everything depending on what layer of abstraction and cross layers you're looking at, is a lot of stuff. It has to be a model so you can filter it down and work with it, okay? And it needs to be malleable. Right? You need to be able to manipulate it, to try different things, to simulate restructuring activities so you can start removing some of these structural anti-patterns, start decoupling the code base. Okay? Some of your options, there's a few tools in this area. One is Sonograph, German company. Another one would be Lattice or IntelliJ IDEA has these dependency structure matrices. Okay? And our own product, Structure 101, uses what we call a levelized structure map. So the restructuring phase of this. Okay? So you need something like that. Okay? You could save yourself a lot of time by going straight to this one, obviously. But they all sell. People use all three. So talking about Structure 101, we've got two main kind of views, models, if you like, and they kind of relate to each other. The first one is the thing here. I'm going to show you this shortly. But the first one here is what we call the levelized structure map. And you can see here that I'll show it to you in detail, so I'll skip over this slide in a sense, but it guides you through the decoupling process, as you can see here, by letting you manipulate stuff, move things around, and see the effect on the overall structural quality, the overall complexity, as you're doing that. So you end up with a list, okay? Then you have someone else go off and make the changes, right? But a lot of the time, the problem with other tools, right, that you'll see, is that they show you, here's a cyclic dependency, and by the way, here's the minimum feedback set. And here's a dependency that's bad. And that will encourage you to go off and fix that dependency. Right? So you look, where's that coming from? Oh, it's coming from this set of classes. They shouldn't use that. You do some, I don't know, create some interfaces to reverse the dependency. You do a lot of work. We don't do that as such. You can use it for that as well. But our emphasis is your containment model right? Right? Before you start blaming this dependency here, is this class in the right place? Right? Is this class in the right place? Okay? When you get it all organized so things are more or less in a good containment model, okay, then you can start the refactoring. Okay? And that's the step that we try to, that's the gap, I guess, that we try to fill. Okay? So this is a very rich environment for doing that kind of work. Okay? Second thing you'll see are what we call architecture diagrams. It's not terribly clear there. But these are diagrams which are very dense. They show the rule of the diagram is basically that code maps to each of the cells in the diagram. So there's a real concrete mapping. Every code item is allocated to a cell in the diagram. Okay? And then the relative position of the cells defines what is allowed to reference what. Okay? And by default, dependency should flow downward. You can override that. Okay? But just that little default, again, gets you around a whole load of different rules that you would otherwise have to express. Okay? So you get a lot of rules expressed for a relatively dense little area. And that's important because it has to be easy to understand. It has to fit inside the developer's IDE and that type of thing. Okay? You can also express things like visibility in here. So you can say this is private. Right? So that shouldn't be used, even though it's a package. Right? These are things that are not code items. These are groupings of files. You're saying this group of stuff should not be used outside of this pink box, right? Whatever that pink box is. Okay? And that's getting into modularity, information hiding. Okay? So they're the two things that we do. And the process typically of starting this, and this is assuming the much more interesting case where there already is a code base. Okay? If you're starting day one, you create an architecture diagram. That's kind of easy. Right? Not very interesting at all. Right? What people much prefer to do is wait until they've got a complete disaster on their hands, a complete tangled code base, and then say, oh shit, we better do something about that. Okay? Now, in fact, I sort of sound skeptical of it. In fact, that's often what you should do to a degree, right? Because day one, you don't want to be starting thinking about, well, what are my architectural components, in a very early stage project, right? You've got a couple of guys working on the early, let's flesh it out a bit and then see what we want. And then you get into around, whatever, pick a number. Bob Martin has said 50,000 lines of code. It's a number, right? Guess what? That's that certain size where you kind of can't really get your head around it anymore. At that point, it's generally pretty easy to restructure it, put some constraints, put some borders, put a picture over the top of it, and say, now let's evolve this architecture in a controlled way. Okay, so that's the ideal. What you normally do, by preference, however, is move to wait until you've got 1.5 million lines of code and you've a team of 15 guys who are just going crazy. And then it can be a challenge, but actually surprisingly easy. Anyway. So step one, discover and define your architecture. So you've got a code base, organize that. This is like, if you like, the bootstrap step. This is before you really get started. There's an upfront thing to be done. Okay? Use the LSM to create a well-structured containment model. Okay? This fat and tangles is something I'll talk about maybe if we get time. And then you use the architecture diagrams to proactively define rules. So structure goes right the way down to the nuts and every function and variable reference and stuff is part of the structure. Right? Anywhere you've got dependencies is structure. And it rolls up through the classes and the packages and the super packages and the projects and whatever, all those different layers. Okay? At some point, it starts touching into what we call architecture. Right? So at some point, then, you're going to define architecture diagrams. And what I sort of say there, you're kind of defining the rules, the structure and the rules that you care about out of all that ocean of possibility. Some of that's more important than others. Okay? So then we're going to create some architecture diagrams and we're going to share them. Okay? So this is step one. This is a bootstrap step. Step two then is ongoing business. Now, once we have that, we're going to go from a situation here, if you like, very simplistically. Our developer's only role is to create code. Okay? Now we're using something like Structure 101, okay, where you've got maybe another developer, the same developer, the whole team. People do it different ways. They have they have architects that's their job. Others sort of just, everybody does everything. I suppose in an agile world, probably this is the development team themselves, right? But anyway, they do some architectural analysis, some definition, whatever it takes, and that gets fed back into the developer's world, okay, as an IDE plugin. So he's going to start seeing now lists of actions. Those actions, what are they for? They're not features, right? They're kind of refactorings more than anything else. Is do these things, and the reason he's doing those things is in order to meet some architectural goals. Okay, so it comes under the heading of refactoring rather than ongoing development. And he also gets architecture diagrams fed back. Now, these are not just pictures. Right? They map to the code, remember. So as soon as he makes a code change that breaks one of the rules defined in an architecture diagram, he's going to go, I get a compilation error type thing, right? So he can't do it by accident, okay, anymore. So he gets compile time checking. We can also do build time checking. Okay, so anyway, if you don't do the build time checking, probably the plugin gets uninstalled, right? Human nature, right? What's measured gets done type thing. So always good to put in a build time check. This is a headless check that takes the code, the new version of the code for this build, takes the architecture diagrams and does the comparison, right? And reports or breaks the build or whatever you want it to do, okay? So basic reporting to whoever. Okay? And then you're into evolution. Okay? You've got this in place. The idea now is that you're, just as your code is expected to change a lot, right? You're in an agile process. Now, it's not just your code anymore. You've got code and architecture. The architecture is an explicit part of your code base, right? And it evolves with it. Okay? Ideally, you're going to update the architecture when required, and in particular, if you're in an iterative development cycle, you're going to plan ahead. You're going to make the architectural changes that are necessary before the developers get the breakage or whatever, and it guides them, right? It guides them during that iterative phase. Okay. Okay, so now I'm going to quickly show you some of this in action, but hopefully it'll make a bit more sense. So, and the way we do that is we go here. Okay. So, what we're looking at here, this is Structure 101 for Java. Works very much the same for C#. There are C++ incarnations that kind of know about the C++ specifics, right? And those that you have typically definitions and declarations and that type of thing. But the key here is this thing here. This is the levelized structure map. So to follow through the two-step process, day one, we're going to come in here. We're seeing we've got a fairly high level of cyclic dependencies here. About 90% of the code base is in a cyclic region, is what that means. When I drill in, I can see here I'm going inside packages, I'm going inside, let me go inside, let's say Jasper here. Here's leaf packages, here's some classes. I can look inside the class, I see the methods and fields. When I select something, I see the dependencies related to the thing I select, okay? So This is the kind of model. Lots of filtering and all kinds of stuff that I won't go into too much right now, but you kind of get the idea of the model, I hope, just from that much. And what we want to do is, we're looking here, this could be, in fact, this is not a particularly large code base, but this could be 1 million lines of code, right? And at the very top level here, if I switch on this feature here, which says basically highlight for me any tangles. So tangles are groups of cyclically dependent items. Okay? And here I see I've got a tangle of 3 items at the top level, right, of this code base right here. Okay? So here are 3 major chunks of code, right? Let's assume they are util, faces, and net, right? And they're cyclically dependent. There are dependencies between them all. If I spread it out a wee bit, you can kind of see here, there are cyclic dependencies between util and faces, and also between faces and net. And all of these things depend on each other. Okay? If at the top level, at least, of our code, we could break up our code into half a dozen chunks that were not cyclically dependent, that would be huge progress. Okay? And quite often that's quite doable. Okay? So first thing I'm going to look at here is what's causing this dependency from util to faces. Let's see if we can get rid of that. And we do that by expanding the util. I'm going to just expand this window here. We expand the util and we see there are 2 classes here. And when I select these classes, I see that both this has a 2-way dependency on faces, but actually doesn't use anything locally within this util package. Likewise, thread local utility there has a 2-way dependency on faces. It doesn't belong here. No one else uses it here. From an abstraction point of view, it shouldn't really be here. So I'm just going to go ahead and move it in here. And I'm going to move this one in here. Okay? And that's removed the util package now from the cyclic dependency that was there, okay, from the tangle. Okay? So I've disentangled, by relocating a couple of items there, I've disentangled this situation a little bit. Okay? Now I'm going to take a look inside. My mouse comes back. Let's look inside here. Okay? Here I've got one package, and I've got this tangle of 3 classes. So the classes themselves are cyclically dependent. What's interesting there is that I know that because these are cyclically dependent, I can't move. There's no point moving one of them. I can move it, right? But I'm still going to have the feedback dependency because the others are part of the same, in effect, the same structural group. Okay? There's no point doing that. So I'll just undo that for a moment. The other thing that's interesting here is that both of the source of both of these feedback dependencies, okay, these are ones that go against the grain. These are the ones that are kind of seem to be the ones causing the cyclic relationships. Okay, both of these are at the top level. Okay, the levels are really important. This thing is constantly levelized, like the Lakos metric that we talked about. We put the things at the bottom don't depend on anything else within the scope. Okay, things on every layer after that depend on at least one item in the layer below. Okay, and it's built up from the bottom. So these things here, it's encouraging to see a feedback dependency going up from something in a top level. Okay, because what that says is that's probably just that's hitting the wrong boundary. This thing here belongs probably at the bottom of faces rather than the top of messaging, if that makes sense. So I know that I can move that guy up there, and it'll get rid of that dependency and won't drag any dependencies with it. Okay? As a sort of a counterexample, if I take something like, I don't know, message selector here, this is down in the levels, right? It's in a middle level here. So it's got lots of dependencies, lots of things in here use it. So if I move message selector up into faces, all those dependencies are going to follow it up, and I'm just going to make the situation actually worse. Okay, so you can see there, lots of feedback dependencies. So we won't do that. But now I'm seeing. So what am I left with? I'm left with this group of 3 things. I'm just going to move the whole group over to faces now, and I've happily disentangled the top level breakout of this particular sub-project here. Okay? And what have I done there? I haven't changed any code. But what I've done is I'm starting to accumulate here an action list. Okay? And these actions can get exported then to the IDE. and you can step through them and navigate to the code, make the changes that are necessary. In fact, we have this now scripted for Java in Eclipse, so it'll just start doing the changes if you're feeling brave. Okay, so that basic process continues, okay? And I'm going to go down one more layer here and do a little bit more of that. Here's another util, okay? I look for what is it in util. This is a real common occurrence. You get packages or files that are called util or utilities, but lots of things use it, okay? And then it starts using stuff. Some sneaky little dependencies come in on the rest of the system. And then that just has a huge coupling effect, if you think about it, okay? So here I'm going to take a look at this guy, and I can see that, what dependencies, I can see that DOM-utils, event is using other things. I could get rid of that. And I think DOM-utils, no, undo, which one was it? Core utils, maybe. Yeah, core utils has a dependency on web app. And I remove that, and util happily sort of falls out the bottom when I do that, which is where it would be. So I'm going to collapse that away. And I'd continue that. Here's another example here. Again, remember I said dependencies sort of flowing up from something on the top. Equally good is dependencies flowing in from something underneath. Okay, so I can see here, if I move that, guess what? Facelets floated up out of the tangle. Okay, now it only uses things in the tangle. It's not used by anything in the tangle. So then it's freed in that sense. So this is a way, and I'm sort of homing in on cyclic dependencies here, because usually this is a good place to start, right? Usually the cyclic dependencies are a great place to start. You know, you can then get into, is it a good abstraction, right? What are my interfaces, right? What should be hidden? All those other great architectural modularity considerations. But that's all kind of meaningless when everything uses everything, right? This is the kind of premise anyway, and I think it kind of stands to reason. So the first step is this. And anyway, even when you get into some of these other concerns, this is how you do the restructuring, right? You drag, you drop. Here I'm showing you just simple moving of items between packages, okay? That could equally be moving methods between classes, or I can create new classes or new inner classes, or all kinds of things. There's all kinds of guidance available on that front. Okay? Now, at some point, so what I've been doing here is moving top down, where I take the existing structure, look at the top level, try and move things around, try and improve things for minimum change to the code base. I'm looking for just the one or two changes that improve the structure. Okay? An alternative way of doing it, if I skip forward a bit, is what I'd call bottom up. So let me go here. Okay? And this is where where I've lost mouse control or something. I'm just going to restart. Do I want to save? No. Just going to restart. This seems to happen when I'm hooked up to an external monitor, not when, it's not that there's a bug or anything like that. So what I want to look at is the middle one. Okay. So in this case, I did a bit of that top-down stuff that I was talking about there. And I got to this point here where I put into this core container here a bunch of stuff that I was just finding it really hard from here on in. So I did the sort of low-hanging fruit type thing on just moving stuff around. And now I've got this area here where, for instance, in the middle of it, I've got this web app, and it's got a tangle of 2 in there, and I look inside HTTP, and it's got a tangle of 3, and it just tangles within tangles within tangles, and just moving a few things around doesn't really seem to hack it. Okay. And what I would do here is use this feature here, which is auto levelize. Okay. So I quite often do this just to try, right? And what this does is it goes down to the raw material, it goes down to the classes, and it groups the classes in a way that all of there are no cyclic dependencies between the groups, right? And all the groups have a fairly high degree of cohesion. So it finds cohesive clusters, organizes them into. It doesn't even try to give these things names, right? So you do have to kind of move in and give them names. Okay, so this one here, what's this? Is servlet-related stuff. So you just rename it in your model. Okay, rename servlet. Servlets, maybe. Okay, so you put that in there, and et cetera, until you end up with, at the end of this process, this ta-da kind of thing, where you can see I've got this right down to the origin. Again, I didn't talk too much about this, but this is basic structural integrity. You've got not too much stuff in any one place, and all your containers are acyclically dependent. If you can get to that, you're 90%. Now I can really start doing interfaces and modules and separate development and phased release and all these great things, right? So that they all become possibilities. So I did that, and you can see here, if I drill into here and into here, this is all acyclic, well-structured stuff. If ever if you don't believe that this is really possible, take a look at the Spring code base sometime. I won't show it to you now, but the Spring framework is like this all the way through. A much bigger piece of code, and there are no cyclic dependencies between packages because they've been doing this since day one. Okay. Now what do? Now we get into I think I'm getting the 5-minute nod here. So I'm just going to quickly show you the architecture diagram. So this is phase 2. Still phase 1. So we're kind of happy with this. We've got a big action list. Maybe someone's working on it, maybe they're not. But now I'm going to go to the architecture diagram thing. And the easiest way here to you can create architecture diagrams, just create a cell, allocate it to some code, set the patterns that map it to the code, all kinds of ways. But the easiest way to do it is to click a button. So expose what you're interested in here of the structure and create an architecture diagram for that structure. And then it's a matter typically of doing a bit of tidying up. So I'm just going to remove some of the nesting here, which kind of just makes it hard to read, doesn't add any value. And I just unwrap those. Okay. I might take some of these things at the bottom here. I might take that. I might wrap those. Okay. And I'm going to maybe call that external libraries. You can give it a name. I won't give it a name now because we're tight on time. And then I can just collapse it. Okay. Collapse it away. So you would see external libraries there because I don't actually care what they are from this particular part of my architectural story. I can have many architecture diagrams. Okay. And now I can start adjusting this, right? So for instance, this is at this location ultimately because this is what the code says it kind of seems to belong. But maybe it doesn't from an architectural point of view. Maybe it belongs there. Okay. And when I move it there, I can say, actually, now I've got a violation. Here's a bit of code that violates the layering rule that I'm describing in this diagram. Okay. Another thing I could do is I could say, well, you see the session utils. That's a utils thing. I just want it to be local to the effects. I don't want anyone external using it, so I can change the visibility of that to be private. Okay. Now I've got a violation, although it's a downward violation. It's breaking my visibility constraint. Okay. So I can do a lot of this kind of manipulation, take selections, subsets of my code, and create ultimately a set of rules here in a bunch of diagrams. How many diagrams? How big's your code? How much detail do you want to get into? Typically, you're going to have a top-level diagram where you've got the major components. How do they relate to each other? And then you might have a separate internal diagram for each of those major components. You may also have a horizontal diagram, which talks about, rather than the vertical services or whatever these things are, you might talk about your tiers. And you might express in that diagram, pull the code using patterns from all of your tiers to the data access layer. Pull all of the code to the business rules layer. Pull all the code to the user interface layer. And just put them in a row so that you can't get dependencies flowing back up. Okay? And at the end of the day, it's all about making it happen And how do you do that once you've got these pretty pictures, which are not pretty pictures because they map to the code, remember I said, you're going to go to the, where are you going to go to? You're going to go here. Here's your pretty picture now inside the IDE, okay? And it's been set up so that it doesn't break, it doesn't report errors, okay, on existing problems, only ones that the developer introduces, new ones. So you can establish an architecture today, even though there are architecture violations, get your developers to continue working, and then they'll get these errors, which they can, oh, what was that? And go here. Say, oh, that's a problem, is it? Okay, so let me, Command S. Okay, now it's gone away. That violation has gone away. And these are just warnings now, these ones here, because they were already in the code. There's someone else has already done that, okay? But anyway, that gives you, I guess, a kind of a flavor that this is a real-time check in a visual way for your developers. Okay? So on that note, I'm going to stop, invite maybe a question or two, if we have time for that. Go here and go here. Yes?
What would you measure, say you as you make those changes and you factor your structure, what would you be measuring to see the data point?
Well, there's we've sort of the one thing we do measure is the degree of cyclic dependence that's there. Okay, so that in a sense is, are you getting it right? We sort of highlight a bunch of notables where you might have disconnected groups, you might have a mix of detail in different groups, and there's a bunch of other things which you may or may not consider problems. We do try not to get too heavily into, here's a metrics framework that is definitive, decider on what is good and bad. Ultimately, that's up to the architects. But we do provide, in particular, the cyclic dependency and too much complexity in one place. Those would be the two main ones that we would measure.
Should you see, like, in terms of outcomes, lower rates of bugs or faster change, or could you do an outcome-oriented metric? Could it self-learn, like, so rather than, you could say, here's the outcome, we're measuring it. We could then say, try these things out and then see. Do more an experimental approach as opposed to a. Because inherent in your cycle dependency is some inherent truth or something. Yeah. But how do you track the outcomes?
I suppose. Well, what you'd like is to you would notice that, right, through your own bug tracking system and what have you. That let's pick a component. Let's see if we can define its architecture, remove any cyclic dependencies. And then over time, you hopefully see some kind of productivity measures improving. But we don't attempt to do that ourselves. We kind of scope it to, let you manipulate and rationalize and define your architecture. After that, you can prove that it's better or not. I think it's a very interesting research topic. Yeah.
Let's say we've resolved all of these cyclic dependencies. Now we have three cyclic dependencies. Let's say we are moving to microservices-based architectures, as previous speakers said. The problem there is that, let's say, if I have two different components or two different microservices, they depend on one microservice. I have to release that microservice on which other microservices are dependent. How do I make sure that when I'm releasing this and there's no impact on the microservices that depend on this?
I suppose that opens up a whole world of questions of microservices and, can you tell anything statically? Do you really need to be monitoring this at runtime and that type of thing? It's actually things that we are looking at. But in terms of that, if there are static dependencies, then you will see them in the model. This is all work. Everything that you've sort of seen today is based on, you have a code base, there are dependencies within the code base. How do we decouple the dependencies statically to help your developers progress? And of course, a large part of microservices is you're not going to say anything about dependencies really until the very end, until runtime, right, to a large degree. And so a lot of that information isn't there, and you can go off and you can create microservices in a sense on an island, and you don't care about the other microservices in a sense. So it's an interesting area.
I think one of the problems with microservices is not tracking dependencies. I think it was Netflix example where something failed, it didn't know it was connected there, and it took out the whole thing. So you have black swan events, you know.
Yeah.
So you do need something
where
like
interfaces and tests for that.
yeah. But so this correlates with that. It can help you maybe put structure on your microservices.
Yeah, I mean, it's a really interesting one because obviously, like our story with microservices is to get to microservices from an existing code base, you need to do something like this. You need to decouple and what have you. So we can help you do that. The runtime kind of understanding of what's happening when I've got 100 or 1,000 microservices and they're all kind of like somehow dependent on each other, I still do feel the need. I know that they're all little autonomous little things, and in theory I shouldn't have to care, but I think people do express this quite often, which is I'd love to see what's going on at runtime. But we don't really do anything about that at the moment. So. Okay, well, great. Thank you.
So thank you for that. That was very interesting. We're now going to break for lunch.